Hello everybody. As you may know, we didn't have enough time to discuss problems 5, 6, 7, and 8 of part 3 of the first season of POMO. So I'll explain problem 6, 7, and 8. So I'm Mateo Espocia. I'm one of the test solvers again. Let's start. First problem. So we have a permutation. So what a permutation is just a reshuffling. So for example, a permutation of this list could be something like 3, 6, 2, 1, 4, 5. And we want to find if there exists exactly one set of real numbers. So this is held. So it's nice in these problems to test out different permutations and see what works, what doesn't work, and what makes a permutation work. So we can do some casework. So, for example, you have b sub I plus b sub a sub I is equal to I plus a sub I. So let's substitute 1 to 6. So if we have I as 1, we're gonna have b1 plus b3 is equal to 1 plus 3 or 4. I is 2. We're gonna have b2 plus b6 is equal to 8. I is equal to 3. b3 plus b3 plus b2 is equal to 5. 3 plus 2. So I is equal to 4. It becomes b4 plus b1 is equal to 5 again. I is equal to 5. b5 plus b4 is equal to 9, and I is equal to 6. b6 plus b5 is equal to 11. So if you notice here, we have a system of 6 linear equations. So if you notice, so 1 is connected to 3. So 1 is connected to 3, 1 is connected to 4 also, 4 is connected to 5, 5 is connected to 6, 6 is connected to 2, and we have 3. So we can kind of change these to 6. We can like, okay, let's say b1 is something like 0. Then b3 here is equal to 4. b2, so this should be 1. 6, so 6 there is. So b2 plus b6 is equal to 8. So this is 7. This should be 4 because this leads to sum to 11. This leads to sum to 9, so that's 5. And we go back to the start. And if you if you let this be any other value, this gonna still generate another different set of real numbers. So if you have 1 to be, let's say, a, this is 4 minus a plus 1, 8, 9 minus what? 9 is it? No, 7 minus a plus 4, 5 minus a. And as you see, each of these works. So we can plug anything to a and it will generate these 6 real numbers here. And it's not exactly 1. So if you notice this structure, so you have a set of linear equations and they form this kind of cycle thing that makes it doesn't work. So let's try some different set of connections. So we can have like 1 connected to 2 connected to 3, which generates b1 plus b2 is equal to 3, b2 plus b3 is equal to 5, and b3 plus b1 is equal to 4. So if you have done linear equation before and you can solve this So if we let this to be a again, this can be 3 minus a, 3 minus a, that's a plus 2, and a plus 2, that's this is 2 minus a, this is a from the last one, right? And we have here a linear equation that has an a in one side and then no a in the other side. So we can solve for a here, and we can this generates only one solution. So what's a more appropriate way to say this is that since this is a sub 1, so 1 goes to a sub 1, so which is 2, 2 goes to 3, and 3 goes to 1. So it forms a cycle with odd length. So this is the main part of the problem, is to see that these cycles determine the set of linear equations. So if we have, let's say, a even cycle, so let's say 1 goes to 2, we're gonna have something like b1 plus b2 is equal to 3, and b2 plus b1 is equal to 3. So obviously this has infinitely many solutions, so we cannot have these kinds of cycles here. So in here it's just 1 goes to 3, 3 goes to 2, 2 goes to 6, etc. And even 1 cycles are possible, so we can do like 1 goes to 1, so a sub 1 is equal to 1, or b1 plus b1 is equal to 2, or b1 is 1. Yeah, and then it's how we can make it unique. And if you're still not convinced why it should be odd cycles, if you notice in this even cycle, if you let this to be a, it alternates between something plus a, minus a, my plus a dito, and then minus a, plus a, minus a. So this last part here will have minus a with a plus a, which will cancel each other. So which is why we need the cycles to be odd. And yeah, we'll do some casework in here, I guess. So if we have a cycle with just ones, obviously that means everything goes to itself. So this has this makes it this one permutation in this case. If there's 1, 1, 1, 3, so we can choose 3 to form a cycle with. And if you think about it, let's say you have like this cycle 6, 1, 4, it's the same with 4, 1, 6, so you just rotate it like that. So we just choose 3 numbers from this list of 6 numbers. So 6 choose 3 is equal to 20. 1, 5 is the other one. 1, 5, and then 3, 3. So 1, 5 again. You choose 5 from the 6 elements to get 6. Then finally 3, 3. So we can just choose 3 elements from this. Oh wait, hold on. Okay. My mistake. I know. Oh wait. Okay, so there's more. So if we switch this to like we can think of this as arranging 3. Okay, wait. 3 elements in a circle. So there are 3 minus 1 factorial ways to do this here, which means that we need to multiply this to 2. So we have this times 2, which is equal to 40. In this, we need to multiply 5 minus 1 factorial. So 6 times 5 factorial. 5 minus 1 factorial because we are arranging 5 things in the circle. So we choose 5 elements and then multiply it with the how many ways you can arrange them in a circle. So this should be 6 times 24 or 144. Finally, the 3 sub 3 case, So we choose 3 numbers from the 6, and then the other ones, they don't matter. And then we multiply. So the first one again has 3 minus 1 factorial ways, and the other one has a 3 minus 1 factorial ways. So that's 2 ways. This is equal to 20 times 4, or 80. Wait, let me verify the answer. So it's very yeah. So what's the answer here? It's 240, I think. Okay. Yeah, it's the right answer. I was just double checking if the answer is correct. So the answer here is what is you add all of these up, and it's equal to 200 and wait, this is wrong. Wait, what's that answer here? So 120. That's 265. So continuing this, I realized what's wrong. This should be divided by 2, because you can interchange these 2 cycles. So we get here 20 times 2 is 40, and we should get 225 as the answer. So that's how you get problem 6 as 225. So the main idea is to test out different things, and so test out the structure as you see. If if it's an even cycle, it won't work. If it's odd cycles, they generate a unique solution to the linear equation system of linear equations. So the answer here is 225. And also be careful with casework, because I was not careful with my casework. So then, okay,